Ketek was an electrical manufacturer based in Boston, Massachusetts, that produced panel boards and circuit breaker panels. The company was founded in 1954 and merged with ITE Circuit Breaker Company in 1965. ITE Circuit Breaker was eventually acquired by Siemens in 1985. The fuses described in the panel board are likely Type S fuses. Type S fuses are small, cartridge-type fuses that are typically 2 inches long and 1/4 inch in diameter. They are mounted on a plastic holder that can be removed by a handle. The holder is 3 inches by 5 inches. Type S fuses are designed to protect against short circuits and overloads in electrical circuits. They are commonly used in residential and commercial applications. Due to the lack of identifying marks on the fuses themselves, determining the specific type of Ketek Type S fuses is difficult. If you have further questions or concerns about the panel board or fuses, it is recommended to consult with a qualified electrician for assistance. Let's delve deeper into electrical panels, fuses, and circuit breakers, essential components for electrical safety and distribution in buildings. Electrical panels, also known as load centers or breaker boxes, serve as the central distribution point for electricity within a building. They receive power from the utility company and distribute it to various circuits throughout the building. The main components of an electrical panel include the main breaker, branch circuit breakers, bus bars, and grounding system. The main breaker is the primary switch that controls the flow of electricity to the entire panel. It allows you to disconnect all power in case of an emergency or when performing maintenance. Branch circuit breakers are individual switches that protect each circuit in the building. They trip or disconnect the circuit if an overload or short circuit occurs, preventing damage to wiring and appliances. Bus bars are metal strips that distribute electricity from the main breaker to the branch circuit breakers. They provide a common connection point for all the breakers in the panel. The grounding system provides a safe path for electricity to flow in the event of a fault. It helps to prevent electrical shock and damage to equipment. Fuses and circuit breakers are both overcurrent protection devices, but they operate differently. Fuses are one-time use devices that melt and break the circuit when an overcurrent occurs. Circuit breakers are reusable switches that trip and disconnect the circuit. Fuses are typically less expensive than circuit breakers, but they require replacement after each overcurrent event. Circuit breakers can be reset after tripping, making them more convenient. Type S fuses are designed to prevent the use of fuses with higher amperage ratings than the circuit is designed for. This is achieved through the use of different sized threads or adapters that only allow the correct amperage fuse to be installed. This feature enhances safety by preventing overfusing, which can lead to overheating and fire hazards. When selecting fuses or circuit breakers, it is important to choose the correct amperage rating for the circuit. The amperage rating should match the maximum current carrying capacity of the wiring and the appliances connected to the circuit. Using a fuse or circuit breaker with a higher amperage rating than the circuit is designed for can be dangerous and can lead to overheating and fire. It is also important to consider the interrupting rating of the fuse or circuit breaker. The interrupting rating is the maximum amount of fault current that the device can safely interrupt. The interrupting rating should be high enough to handle the potential fault current at the installation location. The electrical panels and overcurrent protection devices must comply with various safety standards and regulations. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation and operation of electrical systems. The NEC specifies requirements for wiring, grounding, overcurrent protection, and other aspects of electrical safety. Regular inspection and maintenance of electrical panels and overcurrent protection devices are essential for ensuring electrical safety. It is recommended to have a qualified electrician inspect your electrical panel at least every 3 to 5 years. During the inspection, the electrician will check for any signs of damage, overheating, or corrosion. They will also test the operation of the circuit breakers and fuses to ensure that they are functioning properly. If you notice any of the following signs, it is important to have your electrical panel inspected immediately. Flickering lights, frequently tripping circuit breakers, burning smells, or discoloration around outlets or switches. These signs may indicate a potential electrical problem that could lead to a fire or electrical shock. When working with electrical panels and overcurrent protection devices, it is important to follow all safety precautions. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Here's some more information to provide a comprehensive overview of electrical systems, covering various aspects from basic principles to advanced concepts. Firstly, understanding the fundamentals of electricity is crucial. Electricity is the flow of electric charge, typically electrons, through a conductor. Voltage, measured in volts, is the electrical potential difference that drives the flow of charge. Current, measured in amps, is the rate of flow of electric charge. Resistance, measured in ohms, is the opposition to the flow of electric charge. These three quantities are related by Ohm's law, which states that voltage equals current times resistance. Secondly, there are two main types of electrical circuits: direct current, or DC, and alternating current, or AC. In DC circuits, the current flows in one direction only. Batteries and solar panels are common sources of DC electricity. In AC circuits, the current periodically reverses direction. The electricity supplied by power companies is typically AC. AC circuits are more efficient for transmitting power over long distances because the voltage can be easily stepped up or down using transformers. Thirdly, electrical wiring is essential for connecting electrical components and devices. Wires are typically made of copper or aluminum, which are good conductors of electricity. Wires are insulated with a non-conductive material, such as plastic or rubber, to prevent short circuits and electrical shock. The size of the wire, measured in American wire gauge, or AUG, determines its current carrying capacity. Larger AWG numbers indicate smaller wires, which have lower current carrying capacities. Fourthly, grounding is a critical safety measure in electrical systems. Grounding provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Grounding systems typically consist of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel and all metal enclosures. Fifthly, overcurrent protection devices, such as fuses and circuit breakers, protect electrical circuits from damage due to overload and short circuits. Overloads occur when the current in a circuit exceeds its rated capacity. Short circuits occur when there is a direct connection between 2 points in a circuit bypassing the normal load. Overcurrent protection devices interrupt the flow of current when an overcurrent condition is detected, preventing overheating and fire hazards. Sixthly, electrical panels, also known as load centers or breaker boxes, are the central distribution point for electricity in a building. They receive power from the utility company and distribute it to various circuits throughout the building. Electrical panels contain the main breaker, branch circuit breakers, bus bars, and grounding system. Seventhly, lighting is a major application of electricity. There are various types of light sources, including incandescent lamps, fluorescent lamps, light-emitting diodes, or LEDs, and high-intensity discharge, or head, lamps. LED are becoming increasingly popular due to their high efficiency, long lifespan, and compact size. Eighthly, electrical motors are used in a wide range of applications, from small appliances to large industrial equipment. Electric motors convert electrical energy into mechanical energy. There are various types of electric motors, including AC motors, DC motors, and universal motors. Ninthly, transformers are used to step up or step down voltage levels in AC circuits. Transformers consist of 2 or more coils of wire wound around a common iron core. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determines the voltage transformation ratio. Tenthly, electrical safety is paramount when working with electrical systems. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Finally, here are some additional points to enhance your understanding of electrical systems. Firstly, understanding three-phase power is important for many commercial and industrial applications. Three-phase power consists of three AC voltages that are out of phase with each other. Three-phase power systems are more efficient than single-phase power systems for delivering large amounts of power. Secondly, power factor is a measure of how effectively electrical power is being used. A power factor of 1 indicates that all of the electrical power is being used to perform work. A power factor less than 1 indicates that some of the electrical power is being wasted. Power factor correction can improve the efficiency of electrical systems and reduce energy costs. Thirdly, harmonic distortion can occur in electrical systems due to nonlinear loads such as electronic devices and variable frequency drives. Harmonic distortion can cause overheating of transformers and other equipment, as well as interference with communication systems. Harmonic filters can be used to reduce harmonic distortion. Fourthly, surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or other events. SPD divert the surge current to ground, preventing damage to sensitive electronic equipment. Fifthly, uninterruptible power supplies, or UPSs, provide backup power in the event of a power outage. UPS typically consist of a battery and an inverter. The inverter converts the DC power from the battery to AC power, which can be used to power electronic equipment. Sixthly, electrical codes and standards, such as the NEC, provide guidelines for the safe installation and operation of electrical systems. Compliance with these codes and standards is essential for ensuring electrical safety. Seventhly, energy efficiency is an important consideration in electrical system design. Energy-efficient lighting, motors, and other equipment can significantly reduce energy consumption and costs. Eighthly, renewable energy sources, such as solar panels and wind turbines, are becoming increasingly popular. These sources can provide a clean and sustainable source of electricity. Ninthly, smart grids are advanced electrical grids that use digital technology to improve efficiency, reliability, and security. Smart grids can monitor and control electricity flow in real time, allowing for better management of the electrical grid. Tenthly, electrical safety training is essential for anyone who works with electrical systems. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Let's delve into the specifics of fuse types and their applications. Firstly, standard fuses, also known as cartridge fuses, are the most common type of fuse. They consist of a fusible link enclosed in a glass or ceramic cartridge. Standard fuses are available in a wide range of amperage and voltage ratings. Secondly, time delay fuses, also known as low-blow fuses, are designed to withstand temporary overloads without blowing. They are commonly used in circuits that power motors or other equipment that draw a high inrush current when starting. Thirdly, current-limiting fuses are designed to quickly interrupt high fault currents. They are commonly used in circuits that are susceptible to short circuits. Fourthly, plug fuses, also known as Edison-based fuses, are designed to screw into a fuse holder. They are commonly used in older electrical systems. Fifthly, blade fuses, also known as spade fuses, are designed to plug into a fuse block. They are commonly used in automotive and electronic applications. Sixthly, surface mount fuses are designed to be mounted directly onto a printed circuit board. They are commonly used in electronic devices. Seventhly, resettable fuses, also known as polymeric positive temperature coefficient, or PPTC, devices, are designed to automatically reset after an overcurrent condition is removed. They are commonly used in electronic devices. Eighthly, high rupture capacity, or HRC, fuses are designed to interrupt very high fault currents. They are commonly used in industrial applications. Ninthly, Class CC fuses are compact current-limiting fuses that provide high-performance protection. They are often used in control circuits and other applications where space is limited. Tenthly, semiconductor fuses are designed to protect sensitive semiconductor devices from overcurrent conditions. These fuses have very fast response times to prevent damage to the semiconductors. The NEC, specifically Article 240, covers overcurrent protection. It outlines the requirements for selecting and installing fuses and circuit breakers to protect electrical systems from overloads and short circuits. NEC Table 310.15b16, formerly Table 310.16, provides ampacity ratings for various types of conductors based on their size and insulation type. This table is used to determine the appropriate size of conductors for different circuit applications. NEC Section 110.3 provides general requirements for the examination, installation, and use of electrical equipment. It requires that equipment be installed and used in accordance with its listing and labeling instructions. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns about electrical safety. The advice provided here is for informational purposes only and should not be considered a substitute for professional electrical advice.